Okay, this is the my phone just cut because of space, so I had to fix all that. I'm sorry. Okay, so this is the problem. So here we just rearranged the problem. As you can see, we only rearranged only this pattern. Everything was left unchanged. So here is what we need to know. This negative sign here tells us that now we are going in the negative direction. So cos of negative 180 plus x. So if we are going from here this way, if we are going clockwise, then 180 plus is somewhere here, and cos here it's negative. If we were going anti-clockwise, 180 plus was going to be here, and here cos was going to be negative. Therefore here we have negative of cos of x, right, plus the square root of 2. So here we have sine, into, here we have sine of x plus 45 degrees. Remember, now this is some sort of a combination. So now here we have what we call a compound angle. Here we have a compound angle. Remember when I was telling you about sine of a plus b, this is, and here we have something like this. These two things are similar, so this is equals to sine of a times cos of b plus sine of b times cos of a, right? But let's go confirm that. It's not a crime confirming. Yeah, there it is. We got it all correct. So here we are going to have multiplied by sine x times by cos 45 degrees, right, plus cos of x times sine of 45 degrees. We are just substituting. I'm sorry, this is my square bracket. Okay, this is equals to negative cos x plus root 2. So what is cos of 45? Cos of 45 is the special angle. So whenever you have the special angle, it's okay to punch your calculator if you don't know how you're going to get that. So I am just going to punch cos of 45. Cos of 45 is equals to root 2 over 2. So here I will have my sine x times by root 2 over 2. You get that? Plus, here I have my cos of x. Let me write it here as it is times, what is sine of 45 degrees? I'll just go there and punch sine of 45 degrees. Sine of 45 degrees is the same as cos of 45 degrees. It's root 2 over over 2. Yes, it's root 2 over 2. Then I will close my bracket. Then this is equals to negative cos of x plus. So now I want us to distribute these two inside the bracket. No. Before we're doing that, let's have root 2 here times by. Remember, if you can notice, this is a single term and this is also a single term, and here we have root 2 over 2, and here we have root 2 over 2. That means here between these two terms we got a common factor. So let's simply factor root 2 over 2 out. Then we can have sine of x plus cos of x. Yes, so this is equals to negative cos of x plus, so root 2 times, remember we have positive 1 there as our denominator, so root 2 multiplied by root 2 is equals to 2 over 1 times 1, it's equals to 2. You get that, right? So all multiplied by this, all multiplied by sine x plus cos x. This is equals to negative cos of x plus, what is 2 over 2? It's 1. So even if we don't write 1, it's okay. So it's 1 sine of x plus 1 cos of x. So this and this goes out automatically. Therefore, we can have our sine of x. Remember, we're required to simplify this till we get a single trigonometric ratio. I hope that people are seeing how easy is this. I'm not sure if whether this was clear, but what is it to get here? We used we expanded this using our compound formula of compound angles, So then because this and that, because 45 is a special angle, then we know what is sine of 45, and we also know what is cos of 45. Then we got this root 2 over 2 on both sides. So what we did is that we took the common factor here and factored it out. Then this is what we had left on the inside. And then when multiplying this by this is what we got. Then 2 over 2 is the same as 1. So we distributed this one we got from here. Here, this times this is this, and that times that is that. So a negative cos of x plus a cos of x gives us a 0. Hence, these two cancelled out, of which left us with sine of x. Okay, now let's quickly go to another problem. Here's another problem. I am not sure whether it's clear on this side. So okay, how about this? Yeah. So here we are required to find the value now, not the trig ratio. That means we have to get some sort of a certain number. So now let's go and try that problem. Feel free to pause the video and try it on your own. Okay, I'm sure you are done by now. So let's let's just go there. This is the same as, so cos of 360, remember to go to your Cartesian plane, and here is mine, here is mine, here is the problem. Cos of 360 degrees minus theta. So here is my 360 degrees minus, that means from here to somewhere here. That means now my cos, this is on quadrant 4, therefore I will have cos of theta times by, where is sine of 90? Where is 90 minus an angle? Here it's 90, so here it's 90 minus an angle, so this 90 minus theta, it's somewhere here. 90 minus theta, it's somewhere here. So 90 minus theta, it's somewhere here. So that means this is on quadrant 4, on quadrant 1. This is on quadrant 1, and on quadrant 1 all trigonometric ratios are positive. That means we are going to have times cos of theta. We get that, times cos of theta minus now minus our tan squared. Let me go check the problem. Seems like I didn't, yes, I wrote it wrong there, that it's sine squared minus tan squared of 180 degrees. Is it a plus or a minus? Let me go check. Plus theta. I'm sorry about this. I'm also a human people, so I also make mistakes. So tan squared, where is 180 plus an angle? Let's go to our Cartesian plane, please, people. We better not get tired here. So 180, here it's 180, then plus theta, then 180 plus theta, 180 degrees plus theta, it's somewhere here. Therefore it's on quadrant 3, and on quadrant 3 tan is positive. Therefore we're going to have minus. This minus is the minus of the problem, so we're going to have minus into positive tan of theta, tan squared theta. This is equals to 1 over cos times cos is going to be cos squared theta, then minus tan squared theta. This will be equals to 1 over cos squared theta minus, remember, tan of theta is equals to sine theta over cos theta. It's equals to sine over cos. Therefore here we are going to have minus sine squared theta over cos squared theta, right? Is it so? It's supposed to be so. Therefore we are going to have let's let LCD. We need our LCD, and our LCD is cos cos squared theta. Because the denominators are the same, then we simply take one denominator, and 1 minus sine squared of theta. Now we have this. Now we have 1 minus sine squared of theta, and remember this identity. Remember this identity. I'm not sure whether this is clear, but I'm sorry. Remember that sine squared of theta plus cos squared of theta is equals to 1, right? Then that means that cos squared of theta is equals to 1 minus sine squared of theta. So if this is equals to this and this is equals to this, that means this is equals to that. Yeah, I know teachers be like that. Teachers. Okay, now that means that we can substitute this by this, so we can have cos squared theta over cos squared theta. So this over this, it's equals to positive 1. Therefore we have managed to find the value we were looking for. Thank you. Okay, here it's our problem number 4. Here it's our problem number 4. Even here we are required to find, we have to find the value of this. So it's more like we are required to find out that which number is equals to all this here. So this is equals to sine 2x. Let's leave that, let's rewrite that as it is, then multiplied by, remember this negative sign tells us that this angle x, it's on the 4th quadrant. Therefore we are going to have positive cos of x, because on the 4th quadrant cos is positive, plus, then let's rewrite this double angle as it is cos of 2x times by, here we have sine, here we have 360 minus x. So let's go to our Cartesian plane. Let's go to our Cartesian. Here it is. Where is 360? It's 360 minus, here is 360, here is 270. That means 360 minus, it's somewhere here, 360 degrees minus x. It's on quadrant 4, and on quadrant 4 it's only cos that is positive. Therefore sine cannot be positive in this case. Then we're going to have negative sine of x, all divided by sine of, oh, it's okay, 180 degrees plus x. I will simplify this on the following, I will reduce this on the following step. So let's rewrite this. I want us to look at this and also this. Let's have sine 2x times cos of x. Now because there is this multiplication sign, that means this and this are one and the very same thing. So this, a positive times this negative becomes negative cos 2x times sine x, right? Then we all divide this by, so sine of 180 degrees plus, let's go to our Cartesian plane. So we have 180 degrees, we have 180 degrees, we have 90 degrees, then we have this from 180 to 90, then we have 180 degrees minus angle x, on quadrant 2, but then we are looking for 180 degrees plus. 180 degrees plus an angle theta, it's on quadrant 3. That means sine cannot be positive on quadrant 3, therefore we are going to have negative sine of x. This is the paper of 2020. Okay, now let's proceed now. I think it's the final paper. So where are we? Okay. Now let's look very carefully. Remember when I was telling you guys about the compound angles? Where am I going to write this? Okay, I have said that sine of A times by cos of B minus cos of A times sine of B is equals to what? Is equals to sine of A minus B. Is equals to sine of A minus B. I hope people you get this. So when you look at this and also look at this portion here and also look at this here, what do you notice? You tell me that this and this are the same. That means that 2x is the same as A and x is the same as B. That means this is equals to this can be reduced now to sine of 2x minus x, all divided by negative x, by negative sine x. Then this is equals to, what is 2x minus x? This is equals to sine of 2x minus x is equals to x, all divided by minus sine of x. Then this and this cancels out, therefore we are left with -1. Therefore this is the value we are looking for. Therefore this is 100% correct. So now let's go to the last problem of 2021. Let's go to the last problem of 2021. Trigonometry, it's okay. There's no problem with trigonometry. Okay, this is the problem of the day, of the year. Okay, now let's solve for this. Here they require us to, I think we are finding we are simplifying this till we get to the single trigonometric term. I don't think we're finding the value here, just that I'm not sure, but I think